Well, good morning, kids, and happy St. Patrick's Day. Here, Tuesday, March 17th. I'm wearing my Irish green. Now, I am not Irish, but my kids are half Irish. My wife being totally Irish. I'm totally Italian. So my kids are half and half. So is my granddaughter because my son-in-law, Italian dad, Irish mom. So if you have a little bit of Irish in you, happy St. Patrick's Day, even if you don't. So let's take a look at today's lesson. But first, how about an Irish joke? Who is Irish and sits on your deck? Who's Irish and sits on your deck? Answer? Patio furniture. Get it? Like patio furniture? There you go. How about this one? An Irish gentleman is late for an important appointment. So he's driving around a parking lot looking for a parking space. He's so desperate that he prays and he says, "Oh Lord, if you can only find me a parking space, I will give up all me bad habits and attend Mass every Sunday." Well, all of a sudden the clouds part and a beam of sunlight shines right down, revealing an open parking space. And the man says, "Never mind, Lord, I found one." So here we go. Tuesday, March 17th, your assignment is page 376. Well, it says it right there. Oh, this is not too clear. It's just 21 to 31 odd. 21 to 31 odd, okay? Let me teach you how to do that exactly. So for problems 21 to 27, the directions say, write a polynomial equation with integral coefficients with the given roots. Okay, so we have to come up with an equation at the end where the coefficients are integers, like y equals 3x squared plus 5x minus 1. Nothing with fractions in there. But they tell us the roots ahead of time. Well, here's how we do it. If we have three roots, 1, 2, 3, that means we have an x cubed equation. We call that cubic. It has x cubed in it. There we go. So here we go. If minus 3 is a root, if negative 3 is a root, that means x plus 3 is a factor. We know that, right? If x plus 3 is a factor, negative 3 is a root. So negative 3 is a root means x plus 3 is a factor. Also, x minus 4 is a factor. And x minus negative 1 or x plus 1 is a factor. So all we got to do is multiply x plus 3, x minus 4, x plus 1, and call that y. Okay? So we just multiply that out. We'll show that on the next page. There it is again, x plus 3, x minus 4, x plus 1. How do you multiply three binomials? Well, you have to FOIL any two. I FOIL the first two. You get x squared minus x minus 12 after you combine the o and the I and all that. And then times x plus 1. So trinomial times binomial, there's 6 multiplications to do there. So I did x squared times each of those, negative x times each of those, negative 12 times each of those. There's our 6 multiplications, combined like terms. Here is our final result. So that's what you would list for your answer. That's a cubic polynomial, third degree. And the roots are going to be, as we wanted, negative 3, 4, and negative 1. Okay, that's not so bad. Another example. Here the roots are 1, negative 3 halves, and 2. 1, negative 3 halves, and 2. So our factors are x minus 1, x minus 3 halves, which is x plus 3 halves, and then x minus 2. Well, we want integral coefficients. So if we multiply this out, we're going to get a fraction there. You can see that, right? You're going to get negative 3 halves in there, or 3 halves x. That's not integral. So how do we fix that? What if we multiply this by 2? That creates 2x plus 3. See it there in blue? How do I get rid of 3 halves? Multiply by 2, and I get 2x plus 3. Well, you say that changes the equation. It does, but it doesn't change the roots. All they cared about here was the roots. Remember, multiplying by 2, for example, doesn't change the roots at all. So we're good to do this. And now we have that. We just FOIL that out and multiply that like we did in the previous example up here. And you get something like that. See nice integral coefficients. How's that? So the first few problems are doing just that. You can pause, rewind, and go over it again. But that's how you do that type. Not that difficult. All right, the next type, say, solve each equation. Now, if it says solve the equation, it means they want all the roots. Solve each equation given the two indicated roots. So here's the equation, 3x to the fourth, and so on. Well, that's a fourth degree. We call that a quartic. Can you say quartic? Fourth degree, we expect how many roots? Say it. That's right, 4 roots. We don't know how to solve with 4 roots. In fact, we don't know how to solve with 3 roots. We only know how to solve quadratic until by the end of the week we'll be able to solve anything. But at this point, we can't solve quadratic unless we get a little help. I mean, fourth roots, unless we get a little help. They give us these 2 roots here. So if those are roots, that means we can run them through the synthetic division. It should get 0 at the end. Because if one's a root, x minus 1's a factor, so this should come out 0. So run 1 through the machine. Boom, 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 boom. We get 0 like we expect. So now we have 3x cubed plus 8x squared plus x minus 2. And now this negative 2/3 is also a root. So run negative 2/3 through the machine. Which machine now? You take these. Right, we started with the top line. Now we got this. Put those coefficients, run it through, we get 0 again. So now we started with 4th degree. That got it down to 3rd degree. This gets it down to 2nd degree. 3x squared plus 6x minus 3. And now that's quadratic. We know how to solve a quadratic. I try to factor it. I don't think it factors. So use quadratic formula. And you can do quadratic formula where b is 6 and a is 3 and so on. I divided everything by 3. We've got x squared plus 2x minus 1. Remember, dividing by 3 doesn't change the root. So we can do that. Makes easier numbers. I ran it through the quadratic formula. I don't know if you can see that in the corner, but you get -1 plus or minus root 2 down over there. Again, if you use x equals -6 plus or minus 6 squared and so on, it'll break down to that. So might want to rewind that and run that through again. We start with 4th degree. Plug in one of the roots. Doesn't matter which one you do first. You get down to these coefficients. Run through the other root. Get down to that. That's a quadratic. 4th to 3rd to 2nd degree. We know how to solve any quadratic. How about another example? Oh, no. I guess that's the only example. Well, I think that shall suffice. So before I show you the next page, 2 gentlemen are working in the park. Their work is to work in the park, and the first guy is digging a hole. He digs a hole, digs a hole, digs a hole, and the second guy comes right in behind him and fills the hole in. They move down the line. The first guy digs a hole, digs a hole, digs a hole. Second guy fills it in. Finally, someone says, "Hey, what are you guys doing?" And they say, "Well, usually we're a 3-man crew, but the guy who plants the tree called in sick today." That's not an Irish joke. That's a generic joke. All right, so tomorrow, here's what you're going to see, a little preview. Tonight, you've got that homework on 376, right? 21 through 31 odd, 376, the pages on the GC. And then tomorrow, I'm going to post a 4-page worksheet. Might even post it today, but on that 4-page worksheet, here's what you do. Page 1, all. Page 2, just the circle problems. Page 3 at the top, there's just a couple problems, 1, 2. It'll be clear to you. Keep this picture and go to the worksheets and you'll see, oh, here it is. Page 1, do the whole thing. Page 2, the top part, there's a couple circle problems. In the bottom part, there's a couple more circle problems. And then page 3, we're just going to do up here in page 3. How about page 4? We'll wait another day for that. So that's Wednesday. And then on Thursday, I don't think I'm going to give you a lesson. I think we're going to try the Zoom. I got the Zoom account. I'll figure out how to invite you guys. How about 11 a.m. on Thursday? Does that work? I could do it as early as you want, but I thought 11 might be a good time for you. So let's try that Zoom conference on Thursday, and that'll give you an opportunity to ask any questions for homework 375, 376, and also on this worksheet. So any questions about any of that, give me an email or a comment on Google Classroom or whatever you like to do. In the meantime, stay safe and enjoy the rest of your St. Patrick's Day. Oh, no.